All right. Welcome to week 3 of your AP Calculus course at Biola Youth Academics. My name is Bethany Curia, and this week we are going to be talking about limits. This is our first topic that should be new information for you guys. This should be your first calculus-based topic. Now notice that week 3 covers chapter 2 of your textbook. So you can skip ahead if you want, but chapter 2 will be what your assignments and our discussions and today's video will be based on. Please notice the increase in vocabulary for this chapter. This time I did not give you guys all of the definitions. Your definitions can be found in your textbook. They can be found throughout chapter 2, as well as in the glossary. I know it sounds easier if you go ahead and try to plug it into Google or Wikipedia, but they may not use the same definitions for calculus on those websites that your AP exam and your textbook use. So please use chapter 2 or the glossary and become familiar with these terms. These terms are going to be very common on the AP exam. You do need to be familiar with the definitions and be comfortable with them. It's a really good opportunity to use Quizlet if you're not already, or make note cards and make sure you know the vocabulary, because I can promise your AP exam items will assume that you know what these words mean. They will not take the time to define the words for you. So please make sure that you take the time to become familiar with these words. You'll see the topics line up in the same exact order that they're found in the textbook, all the way throughout section 2. And I did lump some of them together, like the limit laws, limit theorems. You see the sandwich theorem listed in the vocabulary. Please make sure to note that that should be the squeeze theorem. And then you see several talking about continuous functions and the continuity test. That's going to be what we highlight in this video today. The rest of it should be pretty straightforward and self-explanatory, and Coursera does a great job with it, as does Khan Academy. So here's a quick outline of Chapter 2. We have rates of change and tangent lines, limit of a function and limit laws, the precise definition of a limit, one-sided limits, continuity, and limits involving infinity. You have 6 sections in this chapter, but only 1 week, 5 days to get everything done and get through the material. So please pace yourself. Get a head start on the work early and make sure you're comfortable with the material. As far as what's available online, you do have videos from Khan Academy as well as videos from Coursera. It is important to look at both. I recommend starting your week by watching those videos, so that way you can be familiar with the content for your homework. I would like to point out that all of the homework does come from the chapter review at the end of the chapter. So you will have all these types of questions mixed up in the homework. This is one of the few chapters where I do actually recommend that you read through the chapter. I won't do that every time, but this book does a very good job of explaining limits, and they do provide a lot of detailed explanation. So that, in addition to the Khan Academy and Coursera, is the recommended reading for this week. I do think that you will find these resources very helpful. I wouldn't be assigning them to you guys if I didn't think they were going to help you out. In the book, please focus on the laws and the theorems. Again, I recommend note cards or Quizlet. Make sure that you have these memorized. They will not be handed to you on the AP exam. The AP exam will assume that you have these laws and theorems memorized. Not only will you see them in multiple choice questions, but you may be asked to provide a proof for one of your free response items, and you will need to be able to be familiar with those theorems in order to get it done. You're also going to have an assignment on the IMAX website. If you have any trouble accessing IMAX, I need to know as soon as possible so we can work together and get that taken care of. This website is really great because it uses questions that have actually been pulled from previous AP exams. This is very helpful, and it's going to get you familiar with the format of the questions for the AP exam. But this is a required assignment. That IMAX assignment for this week is required. It is graded. And I will go over that a little bit again at the end of the video. With that being said, let's jump into some content. This week I'm going to be talking to you about continuous and continuity functions. Functions can be continuous and discontinuous, and you're going to have to be able to explain clearly why it's continuous or why it's not continuous. And I'm going to be highlighting some of the ways that we do that this week. This is a topic that becomes critical throughout Calculus 1. The continuity of functions is very important as we develop this course. According to our textbook, a function is continuous at an interior point C if the limit of f of x as x approaches c equals f of c. That's a really fancy way of saying if you can take c and plug it into the function and that matches the point on the graph and you get a nice clean value, then it's continuous at that point. So if you can plug it in and it works out, it's continuous. So that's the definition of it being continuous at an interior point C. So as you can read below, if you plug in the value and it matches the point, then your function is continuous. Doesn't sound that scary because it's really not. And moving on to the next screen. A function is continuous on a given interval if and only if it is continuous at every point of the interval, which again is a fancy way of saying if it follows a nice pretty line, you don't have any jumps, you don't have any asymptotes, it's a continuous function on that interval. And then a continuous function is one that is continuous on every point of its domain. Now, it obviously doesn't have any points outside of its domain, but if you look at a function across its entire domain, all the possible inputs, and you've got nice pretty outputs, nice clean points, and it follows a straight path, then you have a continuous function. Now, this doesn't mean that it's continuous for all real numbers, because not every function has a domain of all real numbers. So don't allow yourself to get tricked that easily. One type of question that you might see that tries to trick you with this is that you'll have a function whose domain is not all real numbers. And then they'll ask you which interval is it continuous on, and they'll give you all real numbers as one of your domains to try to trick you. Don't allow yourself to be tricked. All right. The continuity test is really popular for free response questions on the AP exam. This is one of my exam tips this week. The AP exam loves to give you a function and ask you to prove that it's continuous at a specific value. And it'll be a value where you look at it at first and you're not quite sure that it could be continuous there. If you plug in a value and you get something like 0 over 0, that means that there's a little more work ahead. So please, please, please make sure you take the time to read up on the continuity test in your textbook. This is something that your textbook does a great job with. I'm going to go over a summary of it really quick. If f of c exists, then c lies in the domain of f. Step 2, if the limit exists, then f has a limit as f approaches c. Step 3, then the limit equals the function value. So basically, if the point exists, then that c value is somewhere in the domain of f. And if that limit exists, then f of c, or f has a limit as f approaches c. So the closer it gets to f, the function has a limit. And then you just plug in your value and go. Moving on to example 1, it's a function given continuous on the given interval. And they give us f of x equals sine of x over x on the interval negative 2 pi to 2 pi. Now, go ahead and pause and take a moment and graph that picture. So hit pause now. All right, have you taken a moment to graph this? Most of you probably reached for your graphing calculator and got some kind of crazy picture like this. Now, that scribbling in the middle, it's not just any old scribble. This goes towards something called an asymptote. This takes me to a very important exam tip. Your calculator wigs out like that because graphing calculators do not show asymptotes. They will not find those values for you. Instead, you'll put in something that has an asymptote and it'll give you a crazy picture like this. In this chapter, you will learn how to find what those asymptotes are and sketch it accurately, and I promise it's going to be worth the trouble to go ahead and learn how to sketch it the way the book shows you, instead of trying to look at this mess and figure out where the asymptote is. So since our graphing calculators don't show us asymptotes, but we can tell from the spaghetti on the screen that there is, in fact, an asymptote, this is a type of discontinuity. And it pops up right in the middle of our interval. So no, this is not continuous on the given interval. There is an asymptote. Now, as you guys will learn in this lesson, and even later on, you'll find an easier way to solve for this asymptote. You'll find that it's at x equals 0. So the function was not continuous. We can look at our picture, draw a sketch, and very quickly find a discontinuity. That means it's not continuous. Now on to example 2. This is a very common type of question to find on the multiple choice. But I'm going to have you guys take it one step further and do the proof as well. That way you're prepared for a multiple choice question or a free response question. Now this asks us to show that the function given has a continuous extension to x equals 2 and to find that extension. What that basically means is they're admitting for you that there is a discontinuity and they're asking you to fix it. To start with, we're going to factor both the top and the bottom and see if we can simplify this rational expression. If we factor x squared plus x minus 6, we'll get x plus 3 times x minus 2. And then if we factor x squared minus 4, we'll get x plus 2 times x minus 2. So if we would like to reduce our rational expression, x squared plus x minus 6 divided by x squared minus 4, we can cancel out that common factor of x minus 2. That leaves us with x plus 3 over x plus 2. This is a much simpler version of what's really the same function. Now if we plug in our x equals 2, we're not going to get a nasty 0 on the bottom. We're going to get 2 plus 3 over 2 plus 2, which leaves us with 5 over 4. This takes me to another exam tip. I know you guys have a lot of those in here today. Your exam tip for this one: don't simplify. Don't turn it into a decimal unless you see your answer choices are decimal. More often than not, they're going to want the fraction. I know it's so much easier to plug it in our calculators and let it calculate the decimal for us, but I can promise you that you need to get used to using the fractions because more often than not, that's what your answer choice is going to be. It's also a very common mistake on the free response section for students to think they're simplifying to a decimal and do so incorrectly and get docked points. We don't want to get docked points, so unless the test specifically tells you to use a decimal, stick with the fraction. So now we have shown that the function has a continuous extension to x equals 2 because we were able to simplify our function and find that extension. We simplified our function, we plugged in x equals 2, and we found that that extension was 5/4. So we've completed both parts of the question without doing too much work. So that's it for the explanations I have. If you guys need any additional help, please let me know. A few reminders for week 3. I do want to take a minute and talk about discussion board posts. Discussion requires a minimum of 1 post that responds directly to the discussion topic. This has been a problem for some of you guys in the past few weeks. I'm grading this for the quality of work. I'm not looking for you guys to punch a time card and show me that you're just showing up on the discussion board. You need to be writing several sentences. Your sentences need to be on topic. This week, you guys are actually given several questions to answer in the discussion board. You'll notice that I was also very specific in asking you what I wanted to talk about. You guys have a couple problems to discuss on there and a couple questions to answer. And I even put down how many sentences I would like for each answer. This also requires a minimum of 2 responses to your peers' posts. A discussion is it's hard to have a discussion if we aren't talking back and forth with one another. So you guys do need to be discussing with one another. This is due Thursday night. And you'll find that the discussion board actually disappears from the site at 11:59 p.m. Weekly conference is at 5 p.m. on Thursday night. If you will not be joining, I do need you to email me. Please don't post on the discussion board. I might not see that until the next day. Please make sure you email me. You guys have my email here. And I sent you guys a couple emails already, so you should have my email. My email also has my personal phone number, so if it's right before and you realize that you're not going to be able to make it or you're having any internet troubles, please contact me directly. If you have any trouble this week, please contact me. I'm here to help you guys with anything that you need. I'm glad to help. Otherwise, I'll talk to you guys on Thursday night. Have a great week.